Okay, everyone. What I'm going to be talking about today is determining the formula of a carbonate for our lab. So let me take a look at my new share. I'm going to go ahead and go to my web browser. And if we look at the lab, we've got identification of the formula of a carbonate. This is the lab we're going to be doing. And here's the background. So just a quick explanation about the background, and we'll get going here. So I'm going to go to my new share, and hopefully you can see what I'm writing here. So you have a jar from your gravimetric analysis lab. And in that jar, you have some calcium chloride, and you have some unknown carbonate, and you have either lithium carbonate, sodium carbonate, or potassium carbonate. There's a number on your jar because the number, according to the key, is a particular type of carbonate, and you don't know what that is. You're supposed to figure out which one of these three it is. It's a very limited list. So collectively, these three things are called carbonates, and in fact, a carbonate in general is an ionic compound with the carbonate ion. So you're going to try and figure out which one of these you have, and you're going to determine it by obtaining the molar mass. Now, normally, this lab is done with different compounds. Normally, you have a sodium sulfate, lithium sulfate, or potassium sulfate. So normally, you have sodium sulfate, and this is sodium sulfate, lithium sulfate, or potassium sulfate. And you have to identify which sulfate you have. So I'm going to go through the normal reaction that we do. So what you do is you take your sulfate. So just like carbonates, sulfate is anything with the sulfate ion in it. So normally you take your sulfate, and you notice that all of those formulas were Na2, Li2, or K2. So here's a sulfate, and you dissolve some of your sulfate in water, and you know the mass. So you want to mass your sulfate. And then you're going to react it with calcium chloride. And this will also be dissolved in water. So you want to mash your sulfate, and this is going to be the limiting reactant. And your calcium chloride is going to be the excess reactant. And actually, we don't use calcium chloride. We use barium chloride in the normal reaction, and you use excess barium chloride. And the deal is that the barium ion and the sulfate ion precipitate, and you get a solid. And the leftover ions combine, and they're still soluble. So this is the reaction that you do. And what you do is you collect the barium sulfate, and then you weigh it. And from the mass of the barium sulfate, you can figure out the moles of barium sulfate, and you can figure out the moles of A2SO4 from your balanced reaction. You take this number here, the moles of the sulfate, and the mass of the sulfate. So I'm going to call this X, and I'm going to call this Y. So you take your mass of your sulfate, you divide it by the moles of your sulfate, and this gives you the molar mass of your sulfate. Uh, this molar mass of the sulfate is then compared to the molar mass of lithium sulfate versus sodium sulfate versus potassium sulfate because their molar masses are different. And that's how you figure out what your unknown is. Now, there are some issues with this. One of the issues is that that we do like is that barium sulfate is not water soluble, while most sulfates are. So what that means is that in this reaction, it's very unlikely for the sulfate from your compound or I should say, it's very unlikely that any other sulfates are going to precipitate. So you can't get a precipitate of a copper sulfate or something else like that if you happen to have some impurity. So that's one of the nice things about barium sulfate is that it is not water soluble while most sulfates are. And in order to ensure the water insolubility, you usually add sulfuric acid, and this common ion effect keeps the barium sulfate dissolved. The more sulfate you can have dissolved in water, the more likely you will keep some of it undissolved if it can be combined with a barium ion. Some of the downsides of using this is that dissolved barium ions are toxic. So we have to be very careful with this lab. If we go back to this formula here and we see that we're using barium in excess, when we collect our barium sulfate over here, we're basically going to filter the solution through filter paper. And the ions in the liquid are so small that they're not really trapped by the paper, the filter paper. They're only trapped by the filter paper if they remain in the filter paper. But if the liquid goes through the filter paper, the ions go through the filter paper. You do have to be worried about any liquid that remains in the filter paper because it does have ions. So you try to rinse those ions out. So barium ions are toxic and we have to collect those. And we don't want this to be done at home. So we're not going to be using barium ions at home. So these guys are toxic, and that's one of the reasons why we don't want to use this particular lab and why we're doing carbonates instead. So you have enough of the background to kind of do this. So if we take a look at the procedure, the first thing you have to do is you have to dry your sulfate. Now, the reason you have to dry your sulfate is because these sulfates are hygroscopic. They will pull moisture from the air. And we want to make sure that our sulfate is pure. So you dry it. You dry it in an oven at 200 degrees Fahrenheit for an hour. Now here, of course, are the safety issues with the lab is you're working with a hot oven and hot glassware. Now, let's think about this. Do we want to put this container in our oven that has a piece of tape on it and a plastic top for an hour? And I would say no. I mean, I'm thinking that that tape might melt. Paper will not combust at 200 degrees Fahrenheit, but you know, you're not going to put something in your oven with paper on it. So what did I do? I simply dumped everything I had for my number 8 into a beaker. These beakers are meant to take heat. So I put this in the oven for an hour. And here's my number 8, all dried out. Okay, so that's the first thing you want to do. Now, you want to weigh about 0.5 to 0.7 grams of this stuff, probably. You can use all of it, but here's something you need to consider. We want to make sure that our calcium chloride is in excess. So another thing you want to do, and this procedure that I'm outlining here is not really the procedure that's written in your lab description. These are just kind of things that you want to consider. So dry the sulfate in the oven at 200 degrees Fahrenheit for an hour and then let it cool. Then you also want to determine the amount of calcium chloride needed for the reaction. And you're going to use 2 or 3 times the amount. We're going to use at least 2 times the amount. So what does X mean? X means times, 2 times the amount. Okay, so what you want to do here, if you're trying to do this, is you want to go ahead and use the one of these with the lowest molar mass. So let's just assume, just for purposes of figuring out how much calcium chloride to use, you could assume you have lithium carbonate. So I keep saying sulfate, but I got to switch now to carbonate. You could assume that you have lithium carbonate. And if you use 0.7 grams, how many grams of calcium chloride do you need? And whatever that number is, you use twice as much. So let's say you figured out how much calcium chloride you're going to need. Let's see what we do now. So I'm going to turn this on. And here I have a beaker that I'm just going to set on here. And I'm going to tare this. And actually, yeah, that'll be fine. I'm going to put in some of my number 8. And I want to use about 0.7 grams, or 0.5 to 0.7 grams, somewhere along that line. Oh, I've got 0.92 grams. That's fine. I'm going to use it all. So you want to weigh your carbonate. Now, I would have figured out ahead of time for my lithium carbonate how much calcium chloride I would need for excess. So here's my unknown, and I'm going to dissolve it in water. So I don't want to use a whole lot of water to dissolve this because it means I'm going to have to filter more later. I'm going to put my paper over here so you can see this stuff is dissolving. And I'm going to add a little more water. And hopefully all of it will dissolve. Okay. And you can see it's still a little cloudy. And I'm hoping that resolves itself without adding too much more water. But if it takes more water, I'll add a little more water. Because I want to make sure that all of the ions are dissolved so that if this is lithium carbonate, that the carbonate ions can react with the calcium that I'm about to add. Okay, so that looks like it's pretty well dissolved. Now I need a container for my calcium chloride. So here's my calcium chloride. And I'm going to go ahead and use this container because I already cleaned it out. And I'm going to put this on my balance. Here. And I'm going to add enough calcium chloride so that if this is lithium carbonate, I will have more than enough calcium chloride to react with my lithium carbonate. Okay, so my stopper's in there pretty well, so I'm going to use my spatula to help unwedge the stopper. I'm going to do it very gingerly. And now the stopper's free. So I don't know how much I'm supposed to use. I'm going to let you figure that out. So here's my calcium chloride. And I'm not really concerned too much about the weight. I just want to have leftover in case I have to do this experiment again because I mess it up. So I'm going to add some water to this. And I want to dissolve all of my calcium chloride. Okay, so I've added some water. This one I don't mind stirring because if I get any droplets on my spatula and they come out of solution, it doesn't matter. Whereas this guy, if I do stir it and droplets come out, I'm pulling carbonate ions out. And I don't want that to happen. So that's why this I just swirled. This is my carbonate. I just swirled. And here for my calcium chloride, I'm stirring. Now, I'm going to add some more water here. I may have to get another container to help this to dissolve. In other words, this container might not hold enough water for all of my calcium chloride to dissolve. So in this container right now is this calcium chloride right here. Okay, now that is going a little slowly, so I think I need more water. I'm going to get another container, but I'm going to pause the record for just a moment. See that a glass appeared out of nowhere because I set that down before I started the recording again. And I'm going to take my calcium chloride and I'm going to pour that into this glass here. And you can see at the bottom of the glass that it's a little cloudy. And so not all of the calcium chloride has dissolved. So I'm adding more water to help it to dissolve completely. And my water bottle leaks a little bit, so that's why you keep seeing me rub the tabletop. Just to get rid of the water droplets on the tabletop. So once again, I'm trying to use the minimum amount of water to dissolve my substances. And we're going to see in a little bit why I'm doing that. It's because we're going to filter this through some filter paper. And we want to do as little filtering as is possible because it takes a fair amount of time. Okay, so that's getting there. I'm going to let that settle. And in the meantime, while that is settling, I'm going to do something else. And that something else is I'm going to take my filter paper. And you want this to be dry. So if you accidentally get it wet beforehand, like I have, that's no good. What you want to do is put this in the oven at 200 degrees for about 10, 15 minutes and it'll dry it out. I'm not going to worry about that because I'm not really interested in getting the real numbers here. I just want to demonstrate. So notice I fold my filter paper over in two and fold it over again in two again. So I basically have what looks like a quarter of the filter paper. This is how we're going to use it. So I'm going to turn this on, my balance that is, and I'm going to weigh my filter paper. So I see that it is 1.35 grams. So I'm actually going to write that on my filter paper, 1.35 grams in pencil. If you do this in pen, it will be removed by the water. So let's see. There it is. You can see the number 1.35 grams. Let's see if that helps. No. All right. So with the filter paper, I'm going to put the balance away. I'm done with that for now. With the filter paper, you can see that I have the middle fold, but if you look at the edges here, I can make a little cone actually, and this is how we want to use the filter paper. So you want to put your filter paper in your funnel so that you have that little cone. And what you want to do is you want to wet the filter paper down with a little bit of water. And what that does is it keeps the filter paper open and in place, as you can see here. And you're going to filter everything into your Erlenmeyer flask, like so. Okay. So my calcium chloride is still a little foggy, but I believe it's good enough to use. In the best of worlds, what I would do is I would let this settle and I would decant, because then I would have a saturated solution. But nonetheless, I think it's okay to use. And what I'm going to do is I'm going to take my pipette here and I'm going to add the calcium chloride to my carbonate. And can you see what's happening? I'm getting a precipitate. That precipitate is either lithium carbonate, sodium carbonate, excuse me, that precipitate is calcium carbonate. What am I saying? Okay. And I want to add enough of my calcium chloride to precipitate all of the calcium carbonate. Now you can see just how cloudy that's looking, so it's hard for me to tell if I'm getting more precipitation or not. And that's why it's important to calculate how much of the calcium chloride you need before you do this reaction. So basically you can add all of that in and you get your precipitate. Now our job is to collect this white material here, the precipitate, by filtering it through the filter paper. So when you put it into the filter paper, you want to make sure that the liquid you put into the filter paper does not exceed the edge of the filter paper, because it'll go around the filter paper and you'll lose product. So I'm going to pour this in here. And it looks like I can't fit it all in there. Maybe I can. Well, I was able to. I got lucky. And I did not exceed the edges of the filter paper. Now, you'll see I've left some chunky stuff behind. So what do I want to do with that? I want to get it into the filter paper. So I'm adding water to help resuspend that chunky stuff, and I'll transfer it into my filter paper when the level has lowered just a little bit. Now I'm looking at the bottom of my funnel, the little cylinder coming out of the bottom of the funnel. And I notice that there's about a drop happening right now, about every 10 seconds. Oh, now it's gotten faster. It's like a drop every second. So if there are 20 drops in a milliliter, it would take you about 20 seconds to filter 1 milliliter. It would take you about a minute to filter 3 milliliters. And I guarantee the amount of water I used for all of this exceeds 10 milliliters. So this is going to take a while to filter. So I'm going to go ahead and transfer this in here. And remember, you do not want to exceed the boundaries of the filter paper. And I'm going to do one more rinse and transfer it in here, but I need to wait for some of the material to filter through. Now, when we are filtering, I'm going to see if I can capture this. We should be getting a clear and colorless solution in the bottom. What is in that clear and colorless solution? Well, there's going to be excess chloride ions from your calcium chloride. There's going to be excess calcium ions from your calcium chloride, because that is in excess. There'll also be sulfate ions from your carbonate ions from your carbonate. And what is remaining behind here as a solid should be calcium carbonate. So remember, some of the calcium ions aren't used, so they will go through with the liquid. Okay, so I've transferred it all in here, and now it's just a waiting game. So what do you do once all of the liquid has filtered through? And it may take an hour or more to do so, in which case you just set that off to the side and you do some homework. The answer is you need to rinse the ions out of the filter. So I want you to imagine that you're washing clothes. After you go through the wash cycle, before the rinse cycle, and your washing machine is spun, you know that your clothes still have detergent in them because when you spin it, there was detergent in the water. And when you spin it, your clothes are still wet. They're wet with that detergent type water. So how do you rinse that detergent out? Well, you add more water and you agitate to free the soapy solution from your clothes, and then you rinse again. And when you rinse again, you do still have soapy water left over, but it's not very soapy at all because the amount of water you add to rinse compared to the amount of soapy water left behind is much greater than the soapy water left behind. So when you rinse again, you probably have 1/100th of the amount of soap in your clothes afterwards. And for people that are really sensitive to soap, you might even rinse again. And if you rinse again, instead of having 1/100th, you'll end up having like 1/10,000th of the amount of soap in your clothes after you rinse a second time. So we don't have a washing machine here. We have a funnel. And when this is done filtering, the wet filter paper will have calcium ions on it. It will have chloride ions in it, and it will have carbonate ions in it that are still in the wetness of the filter paper. So how do we get those ions to go through the filter paper? And the answer is you're going to add some water to this filter paper to help those ions wash through the filter paper and end up in your flask. Now, normally we check our filtrate. That's the stuff that comes through the funnel. We check the filtrate for ions to see if ions are still coming through. So what would be a great way to detect whether or not you have chloride ions coming through solution? And the deal is if we check for chloride ions, we know that every other ion is there too, because if you've got one ion, you've got a whole lot. It's kind of like termites. If you've got one termite, there's a lot. Okay, so to rinse this, I'm going to show you what you would do. And to do that, I'm going to have to take this filter paper and put it off to the side somewhere, hopefully somewhere where, oh, I know what I can do. I have another one of these funnels, so I can show you that. So I'm going to pause our recording again. Okay, so another funnel has appeared out of nowhere. So I have another filter paper here, and I'm going to wet this down just so it sticks. And what we're going to do here is we're going to pretend that this funnel here is the one that I've been working with, and finally all the liquid has drained out of it. So here what you want to do is you want to carefully squirt the edges of your filter paper at the top with water. And you want to do this carefully because you don't want to splash any of the solid in your filter out. You don't want to lose any of that. And so we're going to rinse this from the top down, and the ions should be rinsing down through the filter paper. Now, how many times do you want to do this? You want to do this at least 2 times, a minimum of 2 times. And then you want to let the liquid that you've rinsed with come through the solution. So when you do each rinse, you probably want to wait a good 15 minutes between rinses. And then hopefully, after a time, it may take a long time, it will appear that there's no more liquid in your filter paper, but what looks like a white solid, which is calcium carbonate. So I'm going to do this a little more. Now, it turns out that what you need to do then is you need to get your filter paper to dry. And you need to make sure that you dry it completely and that your solid is dried completely. And you can do a couple of things. One thing you can do is you can just set this aside somewhere for a couple of days and let it dry. Now, if you've waited to the last minute to do this lab, you don't have time to do that. So here, I'm going to empty the liquid out of this. So let's pretend that we filtered all the liquid through, we have the solid. How can we dry this? Well, if you get one of your beakers and clean it out, you can remove the filter paper and actually put it in your beaker like so. So you see, by placing it in my beaker like this, I make sure that none of the solid's going to pop out. And I can put this in the oven at 200 degrees for about an hour. And hopefully this will dry out. If it doesn't dry out, I can heat it again. So at 200 degrees Fahrenheit, the paper should not ignite. Paper ignites at like 400 to 500 degrees Fahrenheit. So the paper should dry out. So just remember that if you're going to use that as an excuse that you got your homework wet, you stuck it in the oven to dry, the teacher's going to ask you, what temperature did you have the oven? And if you say 200 degrees, they're going to say, nice try. Paper doesn't ignite at 200 degrees Fahrenheit. All right. So you want to put this in your oven at 200 degrees. Why 200? Well, because a cooler temp is going to be safer. All right. Put it in your oven for, I'd say, an hour and let it dry. And then let it cool, and then you can weigh it on your balance. Now, when you weigh it on your balance, it will weigh the mass of your filter paper plus the mass of the solid you've collected. Now, whatever that mass is, you want to write it down, of course. And then to make sure that you have removed all of the water from this, put it in the oven again for an hour, let it cool, and weigh it again. If those two weights match, that means that no more H2O came off over the space of an hour. And it's reasonable to assume that if no more water comes off over the space of an hour, then it was completely dry. This is different than the clothes in your dryer, which we're trying to dry. How do you know the clothes in your dryer are dry? Well, the answer is you just feel them because you're okay with them feeling dry and assuming they're dry. But the real way to determine if your clothes are really dry would be to dry them, let them cool, pull them out of the dryer and weigh them, put them back in the dryer, dry them, let them cool, and weigh them again. If the weight doesn't change, they were dry, because the only thing that should be leaving your clothes would be water. Okay, so once you get the mass of your filter paper plus your calcium carbonate, you can then use the moles of calcium carbonate to figure out the moles of your compound. And since you weighed your compound to begin with, you can use the weight of your compound and the moles of your compound to figure out its molar mass and see whether it matches lithium carbonate, sodium carbonate, or potassium carbonate, and figure out what your unknown is. Now, since you don't know what your unknown is, you're going to have difficulty in establishing a level of confidence, but part of your level of confidence will be how close the molar mass comes to one of the three molar masses. After you turn in your lab, I'll let you know which one you had. Now, this lab is one where you're actually going to do a lab report. And the lab report won't be due until well after spring break. But I'm just giving you fair warning on this. This is going to be part of your lab report. I'm going to write a sample lab report for the magnesium oxide experiment, determination of a formula by, can't remember what I called that, but I'll give you an example of what I would expect for a lab report so you can see what I'm expecting. And then I'll give you a week to write up that lab report. Okay, now, during the time we've been talking, I'm looking at my my material that's filtering, and I can see already that over 50% of it has gone through the filter paper, the liquid, I should say. The liquid in the bottom of the container, you can see, is clear and colorless. If that's cloudy, that means you're losing solid, and that's no good. And so you got to start over. Now, if you do have to start over, I want you to know that your filter papers probably do not weigh the same. They weigh different amounts. So, weigh your filter paper again, your new piece of filter paper. If you really get into a jam and you need another piece of filter paper, you can reuse this filter paper and pretend you have no solid in there, but it makes it much more difficult. So you want to get this right on the first try, and then if you can't, definitely on the second try. Okay, so thank you for listening. I'll post this for you so that you kind of know what you're supposed to be doing here. And hopefully you will be successful and you will figure out what your compound is. Now, remember, I said you're going to be writing a lab report on this, but you're also going to be doing a lab write-up on this. The lab write-up should really help your lab report go very smoothly. The biggest difference you're going to find between your lab report, or two differences you'll find between your lab report and your lab write-up, is that in your lab write-up, you're not going to know whether you're right or wrong. By the time you write your lab report, I will have reported to you whether you're right or wrong. But that means in your lab write-up, you must, as a piece of data, write down the number of your unknown. So this one's number 8, and I have a little list that says, oh, number 8 is lithium carbonate or something like that. Actually, I don't have the list yet. But nonetheless, I then will be able to look at your lab write-up and put in the comment section, your number 14 was blah. Okay, so you won't be able to talk about whether or not you were right or wrong with the lab write-up, but you will with the lab report. Also with the lab report, it's going to be more of like a story, a narrative, not bullet points. The lab write-up, I like bullet points just to make it simple. But the lab report is more like a description of what's going on and what you did and why you did it, how you did it, and so forth and so on. All right, so with that being said, I hope you all have a good day, and we're going to pause the recording or end the recording.